Hey there, everybody. So, our next lesson in our unit about exponents and the rules that we follow when dealing with exponents deals with raising a power to a power. In other words, it's when I have a number written with an exponent, and then I've got that exponent raised to another exponent. So, super easy. Let's just really quickly go over kind of how we're going to figure out what that shortcut or secret to the rule is. First, before we focus on this whole thing can look a little bit intimidating. Let's focus just on what we see inside. What's inside the parenthesis? Yep, 3 squared. So if I write that out, 3 to the second power, that's one of them. And how many times is that going to happen? That's going to happen twice. So I'm going to have another 3 to the second power. Now, this can be done one of two ways. First way, 3 squared becomes 3 times 3. This 3 squared becomes 3 times 3. And I see that I've got 3 to the fourth. Or this step can be skipped, and you can use that very first rule that we learned about exponents when we said, hey, if I have two powers with the same base, keep the base the same and add the exponents. So, same base, 2 plus 2 is 4. If you forget that rule, writing it out in expanded form is the way to go. Let's look at question B. I have 5 to the third raised to the third power. So 5 to the third is going to happen how many times? 3 times. So I'm going to write 5 to the third 3 times. Like so. Now, if I need to, this one's going to happen 3 times. This one's going to happen 3 times. This one's going to happen 3 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 to the ninth. Or, same base, 3 plus 3 plus 3 is 9. Last example. First two we did, the powers were the same. This one, our powers are different. Not going to treat it any differently. So 2 squared is going to show up how many times? 4 times, right? So 2 to the second power times 2 to the second power times 2 to the second power times 2 to the second power. And if you need to, each of these can be broken down again. 2 times 2, 2 times 2, 2 times 2, 2 times 2. Then I get 1, 2, 3, 4, 5, 6, 7, 8 2's. So 2 to the 8th power, or 2 plus 2 plus 2 plus 2, which is 8. So now, as before, I need a shortcut. This is a lot of work. I don't want to always have to do this work, and it's a lot easier if I can come up with kind of what the secret trick is to get me from here to here quickly. How did I go from 3 to the second power raised up to the second power down to 3 to the fourth? Be very careful here, because when you're dealing with 2's like this, it works for addition and multiplication. So one might say, hey, I just add the exponents. But I add the exponents when my base numbers are the same. Here, instead of adding, I'm actually going to multiply. We can verify this by looking at that second example. To get from here, 5 to the third raised to the third, down to 5 to the ninth, 3 plus 3 is 6. I don't have 6 5's. I actually had 9 of them. So it's not going to be adding the exponents. It's going to be 3 times 3 to get 9. Same thing here. 2 squared to the 4th power. 2 times 4 is 8. So the rule that we could write is when you raise, let me get my marker. When you raise a power to a power, what happens to that base number? You keep the base the same and multiply the exponents. So we keep the base the same, multiply the exponents. Now, like before, I'm going to get my handy dandy highlighter. I'm going to highlight that rule because that is very important to remember. I'm going to remind myself, hey, this is the rule. Now, let's go ahead and write that rule in exponential form that would work for any number. Following this rule, raising a power to a power, I'm going to keep the base the same. What's my base in this situation? Correct, it's an A. And I'm going to multiply my exponents. What does it look like when I multiply two variables? Correct, in algebra, I do not need to show a symbol for multiplication if I'm multiplying two variables. I just write them right next to each other as an exponent. So this right here is the same thing as this right here. Let's take a look at some examples now. So here we've got 5 to the third raised to the 6th power. If I follow this rule, keep the base the same, what's my base going to stay? Correct, a 5. What would I do to my exponents? Yep, multiply. So 3 times 6 would then give me 5 to the 18th. Next example, 8 to the 7th raised to the 2nd power. Base stays the same, 8. What do I do to these two? Yep, 7 times 2, so this becomes 8 to the 14th power. Pretty easy, yeah? Z to the 5th raised to the 11th. Base stays the same. 5 times 11, this becomes Z to the 55th power. Doesn't change when I throw a variable in there. X to the 3rd raised to the 2nd power. Base stays the same. Take these two. 3 times 2 becomes X to the 6th, not 5th. I want to go over a couple more for you because every once in a while they're going to throw some at you that look kind of like this. This one's a little different because I've got two variables raised up to a power. Now, don't forget, just because these two variables do not have an actual exponent showing doesn't mean there's not an exponent there. There is an exponent there. Remember, that algebra shortcut, a lot of times in algebra, if the value of something is a 1, they don't need to write it. Students have a hard time, or not a hard time, an easy time forgetting that. So what I always recommend my students do is go ahead and put a 1 after that variable when dealing with exponents. Now, this xy raised to the mth power still means I'm going to multiply this exponent by the base, and the base is still going to stay the same. So my first base value is an x, and x to the first, if I do m times 1, I'm just going to have x to the m. My second base value is a y, so I'm going to write it, and then the same thing here. M times 1 is just m. So my answer here, essentially, really what happened is that m just jumped in and stuck itself to both of the values inside. Here I've got a fraction, or as you know, a fraction is nothing more than a division problem in disguise, of 2 powers raised to an additional power. Same idea is going to apply here. This 3 is going to jump on and become this. So this essentially can almost be written like this. A squared raised to the 3rd power divided by b to the 3rd raised to the 3rd power. Still going to follow that same rule. Base stays the same on the top, a. Take those two and multiply them. So 3 times 2 is 6. That should be a 6. On the bottom, base stays the same. 3 times 3 is 9. So this would be my answer for that one. Last one I'm going to go over with you. Thinking here, let's refer back up to this first one. That m jumped on and multiplied itself by both of these exponents. So this 2 is going to jump in and tag itself to both of these. This 6 doesn't have an exponent, but it's the same as 6 to the first power. So this could be 6 to the first power squared times x to the third power squared. Multiply these two, I still get 6 squared times, base stays the same, 3 times 2 is 6. Now, what I do want to tell you, this can be written two ways, and you have to be careful sometimes because it really depends on how whatever assessment or worksheet you're working on wants you to write your answer. This can be written as 6 squared times x to the 6th, or they may want you to take this 6 squared and go ahead and simplify it. If I did that, remember, 6 times 6 is not 12, but 36. So I would go ahead and do 36 times x to the 6th power. So hopefully that makes sense. Hopefully you added to your notes. Email me or let me know if you have any questions. Good luck.